In this video, we'll explore percent increase and decrease. Now, when we talk about a percent increase, it's the increase in a quantity figured as a percent of the original. So if I say that there was a 23% increase in the cost of corn, that's saying that the new value is 123% of the original value. If I was saying decrease, it means it's decreased in comparison to that original quantity. So when I see a decrease in 12% over 3 years, that means it's 88% of what it was 3 years ago in carbon emissions. So there's a couple different ways you can go about solving these problems, and I think there's two options that can be very helpful depending on what information you have. So my suggestion, either of these will work for any of the types of problems you have. Just try to use the one that seems the easiest for you. So one way, if I'm searching for that percent of change, I think it's easiest to think about our new amount minus our original amount. So the change over the original will tell us the percent of change, and that's if we're solving for the percent of change. Whereas if we know that percent of change, it's easier to look at the new amount over the original amount, because I'm going to try to find one of those. And the reason these become simpler depending on which case I'm looking at is because it keeps me from having to deal with distribution and then with the cross multiplication. So it'll just make the mathematics easier in those problems. But either will work for any of the problems you see with percent of change. Now, one thing to pay attention to is if you have a percent decrease, it's going to come out with a percent change that's negative. So that's important to recognize. So say I want to find a problem with the percent of change. Here's an example. Last week I bought a pound of apples for $1.25. This week I bought a pound of apples for $1.75. What's the percent of change? Well, since I'm looking for that change, I would use that first option, which is the new minus the original over the original. And if I do that, I'm going to get that the change was a positive 50 cents in comparison to the original price. And I just cross multiply. I get 1 in 25 hundredths, P equals 50, and then I just divide, and I would get that that's a 40% increase because that comes out as a positive 40. So I would say that the price of apples increased by 40%. Now here's another example. Last week I paid $3.57 for a gallon of gas. This week I paid $3.49 for a gallon of gas. And what's the percent of change? So if I look at this, my new price minus my old price all over the original, that gives me negative 8 cents. It decreased in cost by 8 cents. Now I cross multiply, and what I end up with is negative 2.2%. That means the price of gas decreased by 2.2%. So a negative percent tells me that it's decreasing. A positive percent tells me it's an increase. Now say instead I've got this problem where I have my percent of change and I've got one of my two amounts and I want to find the other. So I bought a used washer for $5.70. Its value decreased by 23% from the original price since it was used. What was the original price? Well, since I know one amount and I know the percent of change, I'm going to use that second formula to find the original amount. And I could use the other formulas, just I'm going to have to deal with some distribution factors that can get confusing for some students. So if I look at this and I plug in my percent of change, I have to remember it says it decreased. Decreased is important because that means the percent of change is not positive but is negative. So when I plug it in, I'm really looking at my new price divided by the original, which I do not know. It's going to equal 100% minus that 23%, because that's my change, all over 100. So what I'm really looking at and saying is that $570 is 77% of my original costs. I cross multiply this, and I would get that the original amount is about $740.26.